My name is Wayne Tolliver. I'm with ShockSense Enterprises. I'm Chief Technology Officer. I'm currently based in Denver, Colorado. I've been a user of tape in a mid-range environment for more than 10 years. Had a heterogeneous computing environment. Had a lot of data that I had to store reliably and provide nearline access to, so I used tape to accomplish that. I also have experience in the storage arena in general. Have certifications as a storage and cloud architect with a major vendor as well. Back in 2010, I saw the need for organizations to address cartridges that have been shocked or mishandled. And we see that cartridges die in one of two ways or reach the end of their life. Overuse is one category, and then the other one is mishandling. And when cartridges are mishandled, it causes the tape edge to be deformed or the leader pin to be dislocated. And so then when users want to go get their data, it's not there. And so this has caused a negative perception surrounding the reliability of tape, and ShockSense saw a need to fix that. They don't. It's the silent killer. The current technologies only allow us to assume that it happened or to guess that it happened. Unless there's physical damage to the tape cartridge housing, or in rare instances when people actually, the operators open the cartridge door and see that the leader pin is dislodged, there's really no clear evidence short of you running it over it with your car tire. So that's where ShockSense comes in, is because we detect that event and then we can allow the systems and processes to intercept it. Systems like media lifecycle management and data integrity verification go back and use resources in the library such as robotic motion and tape time, drive time, to then decide whether or not a cartridge life has been exceeded or if its health is going within the danger zone. It doesn't, though, let you know if mishandling has happened. So the value of ShockSense is that if we detect that shock, then it's a detour, and that cartridge doesn't have to enter those processes which consume valuable resources in the library. We know it's been shocked, its handling limits have been exceeded, and then we can then set in motion other parts of the processes to then reprotect the data on that tape, or clone that tape from good data that's still on disk, or clone it from a known good tape. It's a passive external sensor that just determines whether cartridge mishandling has happened. And what we're looking for is a deceleration of a specific threshold, and so that either happened or it did not. And if it happens, it's a single-use display. It displays a series of black bars, which then is both human and machine readable. So then we can determine then what appropriate action to take with that media. The way ShockSense integrates with the tape cartridges is very unobtrusively. We require users select an alternative version of the standardized barcode format, which then makes room for our aperture for the sensor window. The sensor itself is integrated in the tape label, which is the only place that we could integrate it into the tape without causing a huge uproar in the industry with the cartridge manufacturers, the drive vendors. And so once it's been attached to the tape, we prefer at the factory, the tape is born that way, then we have visibility into cartridge handling for the duration of the life of the tape. The sensor itself, with the display area, is three tubes that are parallel, like three rectangles. And so before it's shocked, those are clear. When it's shocked, then those are completely black. We're in the first stages of development right now, currently developing a prototype, and we're working to develop a label that fits within the parameters of the label thickness standards. So the shock status is displayed in the human readable element of the barcode. So when you look at a tape cartridge label, the lower half is the barcode, and we can't disturb that area. The laser and the picker reads that area. So the upper area, though, is the human readable area. And since humans don't have lasers in our heads or barcode readers, the numbers help us work with the tapes and rack them and sort them. But if we shift those numbers over, then we have room for the aperture for the ShockSense, and that's where that shows. So it's a distinct indicator. Humans can perceive that it's been shocked, but the real benefit is when the library vendors get on board, they can then change the firmware in their libraries to then read that status, and then prevent loading the shock cartridge in the drive, and then take other steps as well. In the first phase, when we launch ShockSense, we're just going to have just the labels by themselves. It's going to take time for the manufacturers to come on board and get this technology integrated with the library. So in phase one, the humans need to pay attention and just not load this known bad cartridge that's been shocked into a drive. And then the operator is going to walk the tape over to the storage administrator, and then he's going to look up that label in his database of his archive or data protection software, then say, oh, I need to mark this tape as bad, and then we're going to then make a new cartridge, from the data that's on disk already, or clone the cartridge so we restore the level of protection that we have. In phase two, what we envision is once the library vendors change their firmware to look for the presence of our status, then what they can do is then report that through their XML server to the archive and data protection applications that are configured and upgraded to be aware as well. And then this can be an automated process that's self-healing, much similar that the disk arrays have now when their storage media drives go bad. This is our long-term vision for ShockSense. We've had several conversations, and there is intense interest in what we're doing. A lot of people have tried to solve this problem. A lot of well-known organizations such as HP, IBM, Toshiba, Apple has patents in this space, as well as Oracle and Storage Tech. And what we have done is we've achieved a patent, a new kind of patent for a new kind of technology that hasn't been awarded in over 11 years, and no similar patents have been filed in over 15. So we're a new entrant in this space, and it's because our approach is different that's what makes us unique. I've worked for SpectraLogic, did a stint with them as a professional services engineer / pre-sales engineer, so the experience there was unique in our nation's capital working with the federal government. What I was able to do is help customers design solutions, and then I was then the person to show up and install the solution, which I really liked. The customers really liked that because like, hey, you just sold us this solution, now you get to come install it. So there's this amazing degree of continuity that happened there, and it really kept me fresh when designing solutions, interacting with customers, because I was doing both sides of the sales cycle. I knew when I dropped media to immediately retire it. But then I saw these reports of people having bad experience with tape and have negative opinions of tape. Then you have, some of the disk vendors piling on and all of that. And so I thought to myself one day, once I got my big tape library, my mid-range SpectraLogic, I thought, why hasn't this problem been solved? And so I started doing research, and then I came up with a solution to fix it. Once I looked at how everyone tried to solve it, I think, well, no wonder the problem remains unsolved. Their solution was wrong. And the solution to the problems, the previous solutions, were born during an era when proprietary was king, and as we know now, proprietary is not king. LTO is the dominant format in the market, so I knew I had to design a solution that was open and non-invasive, and that's what ShockSense is. Where it comes from is my love affair with tape. I really like tape, and I wanted to see it successful and return to prominence. It's economically viable, it's planet friendly, the tape is. There's a whole bunch of reasons I like tape. I believe that ShockSense will change people's negative perceptions of tape, and when that happens, people will come back to tape. Right now, people are using tape because they have to. Once we take away this bad experience, I believe that tape will resurge over time, and so that's why I'm here. I'm not independently wealthy. I did get a little bit of seed money up front to get to this point. I'm very driven. I believe that this is the right solution. I know that ShockSense will be successful because it's a simple, elegant solution. It's simple to manufacture, simple to integrate, and simple to use.